Good morning, everyone. Good afternoon and good evening. Thank you very much for joining us to the third broadcast and this one of the third series of our keynotes of the Global Sanitation Graduate School. Today we have a special host. This is the Asian Institute of Technology in Thailand. And our moderator is Professor Tamarat Kodadep, who is a professor at the Department of Energy, Environment and Climate at the School of Environment, Resources and Development. Professor Tamarat has been very active and quite well internationally recognized for his professional work on fecal sludge management, non-sewage sanitation, sanitation systems, innovation, and wastewater treatment technology. So, Professor Tamarat, I'm going to pass the word to you.
Okay, thank you very much, Tina. Very nice to see you again. Very nice to have these opportunities to very privileged for us to host this keynote for the Global Sanitation Graduate School. I think this is one of the very, very important sessions from the program that we would like to share some kind of insight and also the experience that we have done in the past. AT, of course, we have been working in this field, the sanitation, the technology development, the understanding of the situation in the fecal sludge management toward the SDG, especially on SDG 6. So we have been doing lots of research, lots of this innovation development in the past decades since we got a chance to get the grants from the Bill and Melinda Gates Foundations in 2012 that we started the idea said, well, why don't we develop the toilet technologies that affordable to the people in the regions in Southeast Asia, in Asia in particular. So we have been working more than 10 years to develop this kind of technologies and prototypes. And then luckily, we found out our industrial partners, Mr. Atawut Kumklong, who is one of the best innovator in Thailand that come and help us providing a necessity in the development of the prototype from the lab to the commercializations. Of course, it's not that just easy to invite such a large company in Thailand. SCG is one of the largest company that providing the many products, plastic products, and also many of those petrochemical products as well. So to direct the business models from such a huge investment in the petrochemicals to the toilets industry, it's not that easy at all. But we are fortunate enough to have him, to have his company to join this kind of ventures to develop lab prototypes to the commercialization, to the commercialized product as well. So I think in the first part of this program, we will hear from Mr. Atawut from this the journey of the lab prototypes to the commercialized products. How do we pass with that and how we can achieve? And of course, there are so many challenges in between so that we can learn from the view of the industrial partners like Mr. Atawut. So I think I would like to invite Mr. Atawut Kumklong from the SCG Chemicals, one of the long-term partners of AAT and many others that try to bring all innovations into the commercial markets that we would like to learn from you. So, Mr. Atawut, the floor is yours.
Hi. Thank you for introduction from like Tina's and Professor Tamarat. So it's quite happy for me to share the experience on how to convert the technologies from the universities and go into the market. So my background of my life is more or less on the product development. So that's why it's interesting to convert the technologies from reinvented toilet into the commercial scale. So today we will talk about the sanitation innovations to commercialization, especially in the case studies of the new products that we call the pathogen-free recycled water for the toilet system and commercialization technologies. So let me explain a little bit about. We just have like 30 to 40 minutes of discussions, and I will give you some like informations about how we can do the technology commercializations and what is the pathogen-free recycled waters projects, and we will summary what it is. And the when we talk about a commercialization of technologies, so I would like you to focus on the technologies first. So you see that is the first the this one. I think you see my cursor, right? And if you are in the sanitations, so what you need to focus is the how to do like a safety managed sanitation problems. That it's a big problem that all of us is the researchers, scholars, or students that work in the sanitations, especially like non-sewage sanitation systems, is to understand what is the problems. I think all of us know about the problems. So how we can do it? We're trying to find a technologies that we need some dedication from the university researchers, uh, brainstorm together to have like the providing the technology for solving that kind of problems. And once you get a lot of technologies enough, and then you go for a product development. So when you integrate the technologies into solutions, and then you can get that prototype one, right? So the prototype, and then the prototype, if it works quite well, so it means you can go for the next step. That is to manufacturing into a products and sell. So then the last step is to distribute the technologies to the concerned people, to users. That is the way that we are doing about the product development from the technologies. So the second column to show you that all of the work that I did, I cannot do by myself. I mean that you need to have a partners. The partner selections is the important when you running the project, because of you do something cross disciplinary. So if you try to produce the new products, it's similar like you have waterless toilet flushing system. So it means it's not only one technologies, but you have to combine many technology, right? So we need to find a partner to do a technology development and collect together and combine together, and finally you can get the technology portfolios. This is the first red brand. The red box is the front end technologies. So when you have a lot of technologies, it's similar like Bill and Melinda Gates Foundations. They sponsor or give the funding to many universities around the world to do this job, to try out the technologies and looking for the new solutions. And then he has a lots of the technology in his portfolios. And then they would like us to go for a further step to make the uh, prototype one, and the prototypes will need some engineering partners. The engineering partners like some like suppliers that you can make some part and let the technology is works. And after that is when it works, so you go for the next step. It's the commercial partners. It means the partner that think that is fit to the market, and then you go for develop into mass scale productions and to produce in and sell it into the market. So when you distribute and sell the technology into the markets, I mean you have to work with influencer, user, or even like policy makers to make sure that your technology can be distributed correctly in the target market. So you can see we should have like the work with the many peoples. It means that you cannot work alone. So it means collaborations in this in the technology commercialization is important. So how do we do next? So this is the product development process that I write it down and I present this one in the ISPIM Innovation Symposium as well about this project. So I think when you do a front end, it means you have to get in terms of myself like a company, a big company. So a company have to do opportunity recognitions about the is it this technology is suitable to do the market and sell in the market or not, right? So after we think it's good, so we will do a technologies, feasibilities, identifications, and if you think it's sure, so we go for alliance formations and business model. This means you have to engage partner in each step. That's what I said, right? So when you come to the development stage, you can see this special funnel design, right? So the technology innovation funnel model is the well accepted, right? So when you develop the technologies or buying from others or partner with others, and then you integrating and then try into one product. So our system is mean you have to develop a components of technology, and then you integrate the components, and then you validate the components, and when it works, so you go to selling into the target market. It should be G1 can be one market, a G2 will be another market. And after that, we will do a post-launch review to see that how to improve the system. This is normal product development process that you are working in the collaboration project, especially in the product that you have to find lots of technologies. So if you see small funnels inside the big funnel is the technology A, is mean the technologies that we can develop. So but the technology B is mean that the existing technology that existing already no need to develop, and finally you integrate together to be a one product. So that is the how we can make a new products. So this is the general idea. I think you will understand and how we can do this. So the next is from prototype into the products. So let me say that the we example today is to working with the AIT and Professor Tamarat and the team and to develop some new products. So the first wrap prototype, I think this one is example to show you how the product is changing from lab scale into the commercial scale. So after the proven technologies that to prove that it's work to treat all the solid and liquid. So it's produced into first a big commercial scale, so to trial. So and after that, when you do trials, this is a technology inside, but I don't say so much about that. But it means that we have like solid liquid separations, and then we separate solid go down to the solid treatment, and liquid go for a liquid treatment. So we have a good system and compact system. The results is good, everything is good. But what happened in when you try to push these products into the market? This is the one that we are working as well on the field that we are working. You see the nice the toilet made, and this is a cubicle that is very fast installations within one or 2 days it's completed. So the technology is like if you have a front ends and you have a separations, and the liquid go to the liquid treatment, solid will go for the dryings, and you can get the dry feces, and then you can be a soil conditioner. But the liquid it can go for irrigation or even to refreshing again in the toilet. So the challenge is the front end will be there, and the pipeline should be a little bit have a slope, and so they have some limitation when the technology was implemented into the products. So that one is the user behaviors, and the existing technologies that you're working is they also already use the septic tanks in Thailand. So it means that it's quite difficult to remove everything and put the compact set one unit to replace that. So what we think is, so we have to rethink it again, to redesign, to separate all the solid and liquid. I think so. From the idea is for all-in-one technology. So we will change from all-in-one into the modular thing. So it means you can separate the technology from the liquid size and solid size and separate and do a new design on the technologies. And you will see that after the technology, the first one from the cube one, and now it changed into the many design and modulars. So it means when you do a modulations like this, so it's easy to implement in the market. So you see from the tanks we change the models, and finally you can get a new design of the tank only for the liquid. So when we implement this kind of technologies to the market, we got a lot of exceptions from the market on this particular. So we test in many sites to make sure that we are learning in many aspects of the technologies and to get a feedback, and then we go back to redesigns and changing. So you can see we test like in communities, small toilet in one single toilets and multiple toilets, and the big toilet like large restroom, 45 toilet, or even like the heavy uses like a gas stations or residential flat or small restroom. So we test many things and put and produce in the real productions, and then see what happened when we install on site and use in the real. And after that, we are convert into the new designs and changing. So the first one after we change, so we change from like into blow molding to make a mold and make the tanks is robust and looks nice comparing to the original lab scale design, right? So it's more looks like industrial products that it's good. And this one also the next one that we would like to improve to make the very heavy duty design. This one is can be like bury underground without to make the concrete pit, because we can save cost and installation cost. There's a model. And the latest model that we are working is we make by a fiberglass. The fiberglass is the easiest fabrications of the tanks that I think around the world can make. It's to make us easier to implement this kind of technologies in around the world and can do a local made in the futures. So it means that you can see that we have many series of products for selection in each countries. So the one that I will show is our case studies that we are shipping the technologies from Thailand to South Africa. So we have a good partners as well in the South Africa to demonstration the technologies, and now we are in the stage of the commercialization and manufacturing in South Africa soon. So this is the example of the tank that we are sending to South Africa for installations. They have two big aquatic tanks. This is the 1,000 liters per day per tanks for treating. This is the industrial park, industrial site. I mean the manufacturing. They would like to recycle the water inside because they use a lot of water and some water scarcity in the African perspective, right? So now that is important. So how we can do it? I think my colleagues make the. So we have a septic tank, and then we need to upgrade the water from septic tank into a pathogen-free recycled waters. So this is our system to change that and change the design of the septics, and then put our aquanics and pump the water from that for treating. And after that, we can storage in the tanks, and then we pump to reuse it again for safety. And the system is the quite simple. So now we are develop aquanic with septic tanks. So the septic can be anyway, but we have our special design of the septic is the when you have a front end, right? And you have the 3 chamber instead of 2 chambers of that. We do correct calculations by the expert and the IT to calculate what is the exactly volume of the first chambers and the second chambers. And also we are adding the equalizer tank to make sure that we can have the water accumulation, especially in the peak load uses. And we pump the water from the EQ tank go to like aquatic tanks, And after the treating, we can get a pathogen-free, reusable waters, and we can storage into the tanks. And after that, you see it go back into the toilet system. So this one is we promote this one in India last month in the Ingat Watch program in Hyderabad in India. So we get a lot of interest from the governments and the private sectors that to be 100% recycle of water in the toilets situation like this. So it will be work with the area that have a water scarcity. Like in India, also many part of that. In Africa, also in many part of the area that found the water scarcity. So it means that you can still use normal toilet with a wet toilet, and you can recycle it in reflushing again. And the water also can not only reflushing, it means you can clean the toilet and then it's go back to the septic chambers and everything, right? So it will be helpful on the system. So it means you can retrofit into the system as well. So even you have system already, just add the tank into the system. So what is the benefit of that? So when we do a testing, so the waste is we reduce the septic time for billing, because in some area they have the problem on you have to empty the septic tanks, right? Because every day the water from the septic tanks will treat it and reuse it again. It means that only the sludge that empty. But we also doing the testing in Thailand for a year with single household to have to work with septic tanks. So it once a year now, more than 1 year is no need to empty in Thailand perspective. And I hope that it will be longer than that. So it means that if you work in this concept, so it means like it's very less to empty the sludge from the first chamber. But I have no the data yet, but in 1 year in Thailand now, so we no need to empty in single household. So it means that if you have no need to empty the sludge, right? So it can go for the second stage for the recycle. And the recycle is mean you have to revalue the water again, especially for human wastewater, and then you reduce the utility bills, right? So it means that you can get localized the circular economy principle. So because we talk about the recycle of plastic, recycle of everything, why the human waste needs to recycle and make a revaluing again of the system. So that is our goal of the team that try to recycle everything from our human waste. So this is the model after that. So when we work with the septic, so I mean you can retrofit to existing septic tanks, or you can work by making a new septic. So the new septic now, this one we are use our model, this model for Indonesia in the Bandung, in the West Java, working with the West Java governor to build a community toilet with septic tank, the new design for 3 chambers, and put aquatic on the top. I think this model is also used in Indonesia model as well. So now today is a running operation with a very good result on that. And the this is the cast on size. Oh, so now and we also make a new system we call a prefabricating of the septic part. So we use a prefab and easy to put it on site. So this one is can generate us the flexibility. So the key of the technology, it should give the less limitation to the users. It means that my model is talking about a modulations, right? Modular design. And another thing that is the key drive of the success is the flexibility of technologies. It means that you can retrofit, you can rebuild, you can add on, or you can do everything about the technologies. So it means that you get the ideas and choice of the installation to the customer. That is will be easier for installations. So another way that we are working is the another example in South Africa. This is the residential in Johannesburg. So they would like to have the recycled waters for their toilet room as well. So you can see that is they can put the tanks here and septic tank is around here. This is how they want to do. So finally we put it. So they put aquatic tank underground right? And make a concrete on the top to make it easier to manage. And you see, we put a solar panel on the top of the roof and this control panel on the wall. So it means that our technologies can integrating with renewable energies, especially for solar panels, uh, can let us go for totally off-grid system. It means that you no need to access into the electricity from the grid, right? So now we are work with our solar panels. It's now today they run without or maybe not without, I mean I can say integrated or hybrid system 50-50. The daytime they use this and the nighttime they use the on-grid. And in the future, we discussed to make the battery. If we have a battery, it means that 100% is no need for that. So it means the technology is also flexible to put it in with the solar or without the solar system, right? So that is also the another choice, because somebody asked us that is it they have some like any like consumption that we need to pay for using the technology. So now we reduce the electricity cost by using the solar panel as well. And you see, when we learnings by installations in South Africa, which means we have to learn a lot. Uh, Even like the first time about the logistics and importing things. So on site, foundations making, installation tanks, connection. And you can see that we spend a lot of time for learning curve on selling. You not only like make the product, so you should start selling the product. When you start selling, you will see what is the difficulties of a selling of the technology. Like if you want to import or export the products from countries, right? So it also have some limitations. And uh, when you do like installation on site, so it's another issue that it's quite difficult to put the tanks. And when you excavate the pit, so what happened in that, and after that you system checking, troubleshooting. So it's make me learning a lot on both installation and operation and running. So I recommend that if anyone would like to start the new technology implementation, you have to go for the market, start selling and learning. I think I love the concept of the startup concept, that you should fail fast. I mean, after that you will learn from that and uh, give a pivot point to your technologies and changing something. So for my technologies now, they go to change and change and change many times. But in the cycle of the changing is less than 6 months, so it will make our product go faster. So this is the summary of the key learnings that our team, after installations, we have key learning on each side, and we will bring the learnings to the development team, how to improve both hardware and software system that we are working. And I think at the what we plan to do in commercialization strategies, once we start selling to South Africa or even to India. So we found that the freight cost from Thailand to India is quite high, or even in South Africa also quite high. So and then we check with our partner. The partner, they have a capabilities to produce the technologies the in specific countries like in South Africa or in India. So it's mean the strategy that I think it's work is mean that we should have a local made with local partner and local distributions. So this is the strategies that it mean that you have to find the right partners. The right partner in both the uh, local partners, that they have a good high skill partners, and the partner also can have the good connections with the users and influencers. So in terms of like uh, health and sanitation segment of the world, So more or less, the partner that I work with is the one that used to work in wastewater treatment before. So when they do a wastewater treatment before, it means they have some experience on how to install the technologies, how to take a sample, how to test the wastewater qualities, and also how to connect the users. I mean the potential customer as well. And most of them they have a capability for um, connecting with the government for the government tender projects. I think in any countries they have a good project from the government to improve sanitations. Like in South Africa, they also have a project for improve the toilet for school and also for informal settlement area, right? So this technology also is a one of the technology that can be considered to be solve a problem of that. So our partner try to make the products within uh, to make a local contents of the product. It's more than like 70% or 80%, something like that, to make sure that they can do a tender with the government project. So I think the key is the when we do a business, we should find the right partners. So as I said in the beginning of the first page of the discussion is the importance of the commercialization is a partner starting from the technology partner, right? Like AIT is one of my technology partners that work well and make sure that they have a proven technologies that it prove and then they can treat the human waste, especially for black water, into like the pathogen-free recycled waters. And then we will integrating with our competencies about industry to make it like a design for industry look and also for a market uh, easy to market penetrations. So we combine the competency of the tools and then drive the product into the market. And when it go to the market, right? So it should have a local partner. The local partner is important. So you have to select the right local partners. And how to work with the partners, I think is the key important is your trust. I said that is I'm missing in here is the trustworthy partner. So how to identify that is trustworthy partners. So it's quite easy because if you want to know about the cost of production, they tell you exactly what is cost of productions and how to share the benefits. So I think it's the key important is you have to find the like trustworthy partners that share you everything, share informations, transparency. Even me also as well to share our like the cost and productions and how to make it very cost effective with them. So that is important to drive the technology successfully. So we will do the our commercialization strategy by uh, made local and sell local as well in India. So we're doing the same in India. We are got many partners, manufacturing partners, distribution partners, and work together as a one team to make to improve the sanitation in specific countries. This is the plan that we plan to do, right? So in the futures, I think you can see that we have designed the commercial scale that is maybe fit to. We have many kinds of the series of the product. It depends on how premium that you can pay, right? If you cannot pay so much, you just have like a septic tanks and also add our technologies. And if you need something that more easier, we can have the septic tanks with our aquatic tanks. And if you need a little bit secure, so we will have the cage like that. And also the last one, we can integrating the solar panels. So if you need like more than 1 cubic meters per day for three things, mean you can integrating the unit, right? Connect together. Like if you have two cubic meter size units and you just put two unit next together and then this can treat it for two units. So this is the example of how the technology progress and flexibilities. I think at the end of our discussions today, I mean, is the the summary is the when you go for the commercializations, I think it's the is is the we need to have a right partners. The partner is quite important, and the how you can get the right partner, I think it would be a good competency of the team that should let them see about your transparency on discussions and make sure that you can share the good benefit to them, so that it's important. So this is the my summary on that. So I know any like questions or anything that would like to share, remarks, and anything is welcome.
Yeah, thank you very much, Mr. Atwood. That's very comprehensive, very insightful. The journeys that you jointly come together with us, with the team, with the supporters, with the partners as well. You bringing in not just only your competence, there are many other partners that develop the specific equipment, specific control panels. That also very important. I think we have a couple of questions in the chat box that they like to have. I think no, the very first one is from Nanamaka or Chobo. I'm sorry if I cannot pronounce it correctly, but she asked about that. Is the pathogen-free water drinkable from your product?
So I think it's the we don't recommend for drinking now, right, Professor Tamarat, right? So the
Yes.
one that we have is just the level of the recycle one. So because I think the perspective also. So we also restrictions non recommend even like for hand washing as well. I think more or less is perceptions, and the our pathogen free system is to make sure just like the the disease from the important E. coli, anything is will be killed or something like that, and it's safe enough. We have like a low no smell, like no odor. So it means that it's user friendly for to put into the flushing toilet or even for cleaning the toilet again. So it's not recommended for drinking.
Definitely, it should not. And also that I think the products we try to comply with the ISO
Yeah.
3500, which is the things that recently developed and proposed in the many countries, adopt this the ISO in many countries, so that if we can comply with this standard, so these kind of products can coming in into many other countries as well, I believe. So the
Yeah.
other questions from the Shakil, he asked about that which treatment technology can be most suitable for ensure the safely managed sanitation for rural areas where absent of treatment plant in Bangladesh.
So I think maybe we are here for the on-site sanitation system, right? So because if you wait for the wastewater treatment from the government, is a huge numbers and of the budgets, and also need the land and need like the people to like accepting that we have a water treatment plants next to your house. So why not every house they have their own like uh, responsible for your waste. What I said is, mean you take care of your waste and treatment. So in terms of our technology providers, so we try to make it very cost effective. It means that to make the user to can afford to buy this. So because I'm that's why I'm going for the local made to make like in the cost after we produce in Thailand and go to India. So we found that the cost reduction is more than 40%. So it means that it's more affordable. I think when we can produce a mass volume, it will be more affordable more and more. I think this one is our the target to be develop a simple technology. If you see our technology is not complicated, it's not talking about the membrane system or the high technology equipment thing that is hard to fix, and I think that's one we try to make it very affordable one, and on-site sanitation it should be the answer, right?
Mhm. That's right. I think to answer this in a more academically, the next sessions, another keynote speakers, Professor Jongrat can come and discuss more about the key concepts on this, and also that what are the treatment mechanisms that we can use and wisely select that it is affordable. Of course, we know very well, pretty well, the advanced processes like I would mention about that the membrane technology. It is possible, but the affordability of the people to use those technologies is a big question mark. So that we select other technologies instead. So the other one is about the local partners. You mentioned many times that it is very, very important to define or to explore the appropriate local partners. But what about in this kind of pandemics that we cannot travel, we cannot trust just to talk between the monitors like this? But how do you do with that? How do you find the local
So
partners?
I think it's very good questions. During 2 years of the pandemic, so I think it's critical for us as well. But luckily, we are working with the Bill and Melinda Gates Foundations that have the support us a lot on providing the connections. So it means that when you work in this world scales, I mean you should have the partners that is similar like Bill and Melinda Gates Foundations. It's not only the foundation like that. I think now in every countries they have their own teams. Like in India, that what I went to last month is the Ink at Watch, the one that also working on promote these, and they have a lot of connection with the startup companies and the company that working on the water sanitations. If you go to the right one in each segment, I think it's easy. And I think when you show that your technology is feasible to implement in your country, so they fully support. So I think for myself, I work with the Bill and Melinda Gates Foundations. They have they recommend us, and that just recommend, right? But the key is the ourselves. I mean, see, I have to engage by myself. They just give the name to me, right? And the key is we have to discussions and contact. But exactly from my experience, face-to-face meeting is quite important than the telecom meeting like this. So if we meet face-to-face, I think is success factor is will be increased. So it's similar like last trip that I went to India. So during 2 years of discussion during COVID is take time. So one time that I meet him, meet my partner, everything complete and finish. So I think it's more or less. I think the face-to-face meeting is important.
Yeah, that's another key of success, that the face-to-face meeting, the face-to-face discussion, then we can build more trust to each other, that we can explore, we can understand to each other much better, so that we can trust from each other, make a trust from each other. So the other question related to that, the refugee camps, whether our products can be applicable to those in the refugee camps with the simple latrines or UDP, which is the urine diversion toilets. That possible or not from the Mr. Daphne?
So I also will try that one in the refugee camp as well. So I it's reflect to my thinking about the pit latrine system in South Africa. So we have a plan to replace the pit latrines and have the study with pit latrine by adding the our like septic and our aquanic part for treating instead of pit latrine, because the pit latrines you after it full you have to close it and relocating the cost is will be high comparing to you pay one time cost, and in the multiple like relocation of the pit latrines what is the cost. So if our system can do very cost effective, I think it should be compatible with the simple pit latrine system. I think we can. So
Yeah, I think it is also possible to connect with that the simple pit latrines as well, that the residues that can be managed by your aquatics or products or others. The other important question I see is that how long does it take that from the technology from prototype to the full commercialization? What is
um,
inside?
from my experience, so luckily because we have a good system, so I think we try about 1 year on that to put it on. So after the technology is right and you we testing and also we have a budget as well to run the project and testing more. So that's why we have a short period of time to do a fully commercializations. And okay, we start commercialization after development 1 year, but you have to develop the market as well because this technology is quite new to the market. You have to compete with other technologies like all simple septic tank normal. How to work together with them is another activity. Not only put the technology onto the market, but how to like integrate with the market perceptions is another work that we have to do.
Yeah, I think that that's also the very key parts that if you don't have market ready for these new products yet, it is quite difficult for the industrial partners that how to launch the products into the market if there's no market yet. So I think it is quite important that we need a kind of a consortiums to work in this to activate this kind of market to receive such a new products, such a new innovation into the market. So I think another question is related to that. If you put a product in the market and in turn there are some change to be made to the better, so do you stop the sale of the old one and continue selling the new ones? This is a kind of business strategy, I guess.
So I think actually we try to keep it like a product portfolio. Sometimes we it mean you what I mentioned in the presentation is we have a choice to customers when you get a new versions. So the old version is sometimes is fit to some perspective, and the new product development after you get a new version is make sure that you can go to like higher competitive levels with your competitors, right? If you stay still and not changing and not do development, one time that your competitor will come and to make your product better than you. So we have to do a continuous improvement and make sure that if we like kill our product by ourselves, it's better than let other people kill your product, right? So this is my strategy. So if you compete with your product, it's okay, but don't compete with others, right?
Yeah, that's important that we need to improve by ourselves better than the other kill your products, right? So
Yes.
there would be more advancement anyway from the disinfection technology, from the treatment technologies, from the new design of the products that can get into the market easier to penetrate these products into the market faster. How do we do that? That it is another the strategy that we should do. So the other question is about that again. That how do you justify the investment and for installation of the system and its return, the cost benefit analysis?
So
SCG in particular interest into this kind of a business is where it is not really the big market yet.
So when everyone talking about new technologies, they think about how much of money that company have to invest, right? So the more investment is mean you have to build and do everything by yourself. So my strategy is different. What I said in the beginning about the collaborations, right? What does it mean? The collaboration is mean the share the resource from our partners. What I try to elaborate a little bit more on this. So when my companies, they are working a lot on their plastic production, right? So when we want to make a tanks, so it means that we're working with our partners, that our customer that they already make a tanks, but they don't make a tank with my specification, right? So when we talk with them that why not you work with me, you already have more, you have the facility, you have everything, but you don't have the idea from us. So just share an idea and share benefit and work together. It means that the first investment of the technology is quite, I say that the zero investment for me. So because we work with a partner that already investment in that particular perspective, right? So no need to investment this for my work. So the cost will be low, and let make like a share benefit with our partner with mutual benefit will be great.
Mhm. Yeah, I think that's just very important that to justify the investment I think one of the questions would be that how you justify this kind of an innovation to your board, that whether it is good enough to invest at least for your personal interest or your personal time into these kind of projects. How can you convince the board?
I think it is a good question as well. So you see that I'm so have a good passion to drive this. So because when you work with some technologies and you have to think that that technology is like in strict on your passion or not. If you are thinking you have to work like you are in the startup company and you want to drive your business and you think that if you think yourself and you answer yourself that it's good product and you want to drive this, and that is the key, I think.
Yeah, I think that's also very important to share with the audience that SCG Chemical is not a startup. It is a well-established company, the corporate largest petrochemical companies in Thailand or in the regions that the new things like this, the toilets technology, the toilet industry is far behind the plastics, investment or the revenues they generate from the other plastic products from that. So I think this is very important that how we can convince the SCG, the largest company in Thailand, to invest for such a new toilet innovation. I'm sure that the other countries, they will have many other companies invest as well. But the key thing is that how we can get this kind of person like Mr. Atavut have a passions on this sanitation as well, not just only the plastic polymers, the new innovation in the plastic type of things, but to apply the plastic for other products, for other purposes. That would be interesting. I think Mr. Duck may also ask you about your address and contact, whether they can get from your point of view to get the other contacts for their business set up or not. I don't know. Is that possible?
I think you can easier like write an email the synchronic at scg.com. So synchronic is by was ZYCLONIC synchronic at scg.com. That is you can connect in that.
Mr. Atterwood, I was going to suggest maybe I can post your email address on the
It's okay.
broadcast.
No problem.
Yes, so they can see it.
So
Thank
I think
you
the
so
time's
much.
up, right?
Yes, just to make sure that they get the right contact. Thank you so much. It was so interesting. We have our next speakers in the room. So I would let Professor Tamarat to introduce them. I would just add him to the stream. Professor Tamarat.
Okay, thank you, Tina. So we have the second session that having Professor Jongrak Ponpasert and Dr. Thachai Pusyanawin. Professor Jongrak Ponpasert is an emeritus professor of the Asian Institute of Technologies. Actually, he is my professor, is my teacher, my mentor in the past 20, 30 years. Since I studied at AIT and also became a professor, he's still my mentor anyway. So Dr. Thachai also our team developing this kind of a technologies, another technologies that develop, but we also think about that. What would be the pathways that how we should select this kind of technologies, the lesson learned from the idea that we have had in the past, and then how we can develop, prove that it is possible, it is convincible, and then we can sell the ideas to the market or to the industrial partners. I think we can hear from these two experts from in the field, Professor Jongrak and Dr. Thachai, that one of the other things, the technologies that we developed within we invented the pilot program is that the solar septic tank is not the same solar types, the same solar panels that Kun Atavut mentioned earlier about that, try to reduce the energy consumption by the solar panel as off-grid operation, but the solar septic tank is different. So I will give the floor to Professor Jongrak and Dr. Thachai for this session on sanitation innovation pathways. So please, Professor Jongrak and Dr. Thachai.
Thank you very much, Professor Thamarat. So I am Chongrak Ponpasert. I will start the presentation first. to be followed by Dr. Thatchai. Yes, it is my great pleasure and honor to be here and sharing with you some of our research work that we have done at AIT to reinvent the new toilet technology. As we all know that sanitation problems are still causing health and environmental pollution in many countries, especially in the less developed countries. So we know that for toilet, yes, toilet is a place where we defecate and we urinate. Each one person, we defecate about 200 grams per day, and we urinate or urine about 1 liter per day per person. And we know that these feces and urine are heavily polluted. They contain pathogens that cause a disease. They contain organic matter that cause water pollution, and also nitrogen phosphorus that may cause algal bloom. So what do we do? Next. Can we go next slide, please? So, okay, this is the data in my country. In my country, Thailand, people think that if we provide toilets to the people, then we can solve the health, the environmental problems. In Thailand, about 99% of the people have access to toilet, but that is not enough, because if you come to our country, like in Bangkok City, we can see that our canals, river are still heavily polluted with wastewater, mainly from household, and also people get sick from the diseases, especially enteric pathogens. So that is why next, the United Nations. Okay, so that's why we say that having toilets is not enough. We have to do something else. So that is why the United Nations have agreed to have the SDG, or Sustainable Development Goals, especially goal number 3, which is good health, well-being. Goal number 6, clean water sanitation, and goal number 11, sustainable city, because we all realize that sanitation and toilet are still big problem that causing public health and environmental problems. Next. So like goal number 6, clean water sanitation. So how can we improve? Because the present type of toilet and on-site system for treatment of black water or toilet wastewater do not work well. So the AIT team, we have to come up with new technology. We cannot go on business as usual. We have to come up with some innovative technology, but innovation alone not enough. We also have to have the market-led or capacity development, and also the system will not be too expensive, and we need to have all the data available. That is how our AIT team come up with the new technology. Next slide, please. So this is the present situation in Thailand. We have about 65 million people, and of course, because the household building do not have good connection to sewer, so the regulation is that every household building must have decentralized or on-site waste treatment system. So if you have on-site system like septic tank, cesspool, or commercial septic tank, then there is sludge accumulation, sludge production, or we call septage. And septage has to be properly collected. In Thailand, estimated about 16 million cubic meter per year. And for the wastewater has to be further treated or connect to sewer and then treated in the centralized wastewater treatment plant. The figure below show the vacuum trucks come to empty the on-site system, the sludge from on-site system. Next slide, please. So again, for the ideal situation, as I mentioned, the septic or septic tank sludge collected by the vacuum trucks should be properly treated by the fecal treatment system, and then it can be reused. And then the effluent from the on-site system should be further transport or disposed of in sewer for treatment, because we know that most of the on-site system like septic tank, cesspool, detention time is only 3 to 5 days, not enough to kill pathogens, not enough to remove or biodegrade organic matter and so on. So this is the ideal situation that I mentioned. Okay, next. But unfortunately, in Thailand, we have observed that about 90% of the septic or septic tank sludge is not properly treated. So after collection, the vacuum trucks, in many cases, dispose of the fecal sludge into nearby empty land or agricultural land. And as we can see, the fecal sludge is heavily polluted with pathogens, with organic matter, with nutrients. So that is why water pollution are still big problems in Thailand, not only Thailand, but also in other less developed countries also. Here is example of how the septic or sludge disposed of. In some area, it is dumped into canals. So you can see the potential pollution health problem. Sometimes sludge is dumped into the nearby road or dumped into open areas, dumped into canals. So the situation is becoming worse and worse because we don't have the capacity to treat the fecal sludge, and also the amount of fecal sludge is quite huge, and it is expensive to treat them also. Next. So this is a problem. The data show that about 90% of the fecal sludge, or about 14 million cubic meter, is illegally or improperly dumped into nearby environment, agricultural area, water stream, and the effluent from the on-site system. Only 30% is connected to sewer. 70% are discharged into nearby canals and river or empty land. As I mentioned before, that on-site system have quite short detention time, maybe 3 days to 5 days, not enough to treat the wastewater or black water. So water pollution is a huge problem. Next. Well, this is the global data which show that due to the problem of sanitation and improperly dispose of fecal sludge, so there are about 1 million people who die every year from this lack of sanitation. Well, this is about 4,000 deaths per day. More than even now the COVID-19 or more than bird flu, but people don't recognize a potential problem and so on. So we cannot allow this situation to go on. We cannot allow business as usual. There should be some development. So the researcher from university like AAT, so we try to come up with some new ideas or improvement. Next. Well, once again, these are examples of canals in Bangkok city. Although in the past, 50 years ago, Bangkok canals used to be called Venice of the East. Used to be very nice and clean, but due to the urbanization and discharge of effluent from the on-site system, either septic tank or commercial septic tank, which do not properly treat the wastewater. So the water quality become deteriorated and polluted. As you can see here, we cannot swim anymore. Next. So this is example of the on-site treatment system in Thailand. In the like a rural area or the low-income urban area, household employ like one chest pool, two chest pool, or sometimes septic tank. The size installed for household, the size of this on-site system is maybe 1 cubic meter or less. So you can see that detention time of the wastewater stay in the tank here is 3 to 5 days. Not enough to treat the wastewater, not enough to inactivate the pathogens, and we have pollution problems. These are the photo of like one chest pool on the left side, and then two chest pool. In general, the one chest pool or two chest pool receive mainly toilet wastewater, but then the gray water or wastewater from kitchen, bathroom, and other cleaning in many cases are not put into this chest pool, but discharge directly into nearby sewer or canals. So you can see that pollution problem still occur. Next one, this is the like a diagram of the commercial septic tank that receive toilet wastewater or black water mainly, and the effluent which is not quite clean or still polluted are connected to nearby sewer or canal or water body. So water pollution is problem. I emphasize this because these are the situation in Thailand and also in other less developed countries, and we cannot let this continue because pollution problem and health problem are becoming more serious. Next. So this is the data of the analysis done by the AAT team. We have analyzed the influent into the like one chest pool, two chest pool commercial package on-site system, and also analyze the effluent from this three type of on-site system. As I mentioned before, we found that this on-site system cannot function properly. The organic like BOD still about 150 to 300 milligram per liter, higher than the standard. And the fecal coliform or the pathogen indicator is in the range of 10 to the power of 5, power 8 number per 100 ml, higher than the standard. That is why we have water pollution problem and very high health risks. And for the fecal sludge, we know that on-site system, we have sludge production, sludge accumulation. Either it is pit latrine or chest pool or septic tank. We have fecal sludge or septic that need to be properly collected and treated or reused. Next. So that is why AAT team come up with the idea to reinvent the toilet or technology that is naturally acceptable and technological sustainable or NATS. So we were fortunate to receive the support from the Bill and Melinda Gates Foundation. To develop effective technology for sanitation or a better toilet. And we focus on the on-site treatment technology because in the less developed country, connection to sewer are not very good. So on-site is important. And the foundation emphasized that our technology should be accessible by poor people. That means they should not be too expensive, and also create a platform for the sustainability in the future also. Next. So, well, these are some of the technology that are developed by AIT. I think Kunatawut also mentioned this is the cyclone cube. Next. So in general, from this project, which we have started based on the market-led innovation, we have to find out, do the survey analysis, what did the market need, okay? What can we do to match the unmet needs of the technology? And we also come up with the design material which are appropriate. And to make it feasible, we have to do from the lab scale study, pilot scale, and field validation, including the patent filing. And of course, to make it accessible to the public at large, we have to connect with the manufacturer and so on also. Next. Next one, please. So one of the technology that we want to emphasize is we call solar septic tank, like Thamarat mentioned. So here we use solar energy, which is free or low cost, to heat the septic tank content. So with the solar energy, we can raise temperature in septic tank to be higher, okay, like 45 degrees, 50 degrees Celsius, which can be effective to kill the pathogens. And with high temperature, the organic waste like feces, fecal salads can be converted to become methane gas, and wastewater treatment efficiency become better. In addition, the fecal salads, of course, will be reduced in quantity because the salads will be degraded to become methane and so on. So these are the principle of our development of the solar septic tank. And now Dr. Thachai will explain further the detail of development and how do we apply our technology into pilot scale and full scale testing. Dr. Thachai, please.
Okay. Thank you very much, Professor Jongrak. I will present for the next part on behalf of our teams that develop these kind of the technologies. Then, as we mentioned, the solar septic tank, that is the one of our developed technology from the AIT teams. And then that time we led by Professor Thamarat and also Professor Jongrak to work on these kind of the technologies. And then the key things from these technologies, we try to overcome the problems or the issues based on the on-site sanitation system that we investigate from the maybe last 6 or 7 years ago. And then we found that also several limitations that we have to overcome. The key principle from these technologies, we try to start thinking of the basic concept of the technologies by using the temperatures. And then the principle here is we try to understand what could be the effects on the temperatures in the septic tanks in terms of maybe pathogen die-off and also the speed up of the biodegradations. As we know, the range of the temperatures that the key effects on these technologies, and then we have to investigate. In this state of the development, we call the proof of the principles that we have to set up of the lab scale experiments, then develop further into the several stages to prove our principle here. And then also from this point, we come up with the concept in the second stage. We call this one like a proof of the concepts. When we know the conditions, the operating factors that relate into the solar septic tank, we try to adopt the technologies by using the solar heated waters that we use the kind of the apparatus to absorb the solar radiations and then transfer into the heat, and then we circulating of that kind of the temperatures or the heat into the septic tank, and then that is the concept to rising up the temperatures in the septic tank. And then from both concept here, we can call this is a solar septic tank, that one of the innovative technologies that we working with. And in the pictures or the photo that you can see in the right hand side, that is the first our pilot scale of the solar septic tank that we implement in communities for the one families to use and then to work on this. And then I will discuss in detail for the prototype development against on these kind of the details. For the concept of the technologies, I will show you about the video presentation here. Okay, and this video show you us about the concept of the technologies that we implement and also the develops in during the prototype stage. And then I think you can see about the concept of the technologies. But for the details, how to the controls of the temperatures or to the set up the experiments or the pilot testing, we use the solar heated waters. And that time we use the vacuum tube of solar heated waters to absorb the radiations, and then the the heat or the energy can be the stored into the hot water storage tank in the solar heated water systems, and then we use that kind of the energies circulating by using the pumps into the heat exchangers inside the septic tank, and then it can circulate back into the solar heated water again. And then we use this kind of the closed loop of the circulations to increase the temperatures of the solar septic tank. Then from this concept, and then we also findings with the patent, and then we got the patent from this kind of the process of the solar septic tank in Thailand. And from this kind of the details, it's not only the system that try to heat up, but also inside the design of the tanks that also important. Based on the results from the proof of the principle stage of our technologies, we also thinking of to control the temperature within the tanks by using a kind of the temperature simulations to understand the heat gradients inside the septic tank. Then we control the heat in the centers of the septic tanks by using the disinfection chambers, because in this zone we can see with the during the operations it can be very high temperatures because of it's very close into the heat transfer equipment. And then in this zone we can inactivate of the pathogens in the effluents before discharge into the environment. And in the same times for the septic tank chambers or the anaerobic digester tank that is in the septic tank zone, in the bottom part that we can control the temperatures at about 40 degrees Celsius, which can help to promote kind of the methanobacters that can convert of the intermediate products, soluble forms of the organic matters into the methane, and then it can speed up the degradations inside the septic tank slot as well. And then that is the design for the configurations of the septic tank. And then that is come up with the design based on the principles details that we work on the lab scale. And then this is the figures that we implement in the fields with the versions in the installation period. We install with the septic tank chambers and together with the solar heated waters and also the heat exchangers that we put into the solar septic tank. And from this the prototype and then verify the results, and then we found that it can increase the performance of the maybe when compared with the conventional septic tank. Solar septic tank is seem better in terms of the inactivation of the pathogens. Maybe it can be increased to have more than 3 log reductions in the effluents, and also it can digest faster, and then it can reduce the volumes of the septic generations about the 50%. Then from that one we try to proof in terms of the verifications in the more implementations. Then we got the fundings to implement the pilot testing of solar septic tank in several countries. Then one of that in more than 10 units that we implement in Thailand, and also 5 units that we implement in Cambodia. And then also we monitoring the treatment efficiency of our unit more than maybe 4 months, or it can be up into 3 years, like a long-term operations. Then this is a 10 pilot unit here. And then you can see with the several designs and then modifications based on the kind of the limitations or any technical issues. And then we try to develop with the several versions of the solar septic tank at that time. And then we implement in the schools, in the communities, and also maybe in the some the constructions area as well. And also another interesting thing is that we got the fundings from the ADBs. This is our teams implements another versions of the solar septic tank we call the low cost solar septic tank, made of the plastic pipe into the like a low cost version of solar heated waters. And then we implement the technologies in Cambodia in the individual households and also in the primary school. And then also this is we monitor the results in terms of the pathogens, the organics, pollutants, and also the sludge accumulation as well. And this is a details of the technologies that we made for the Cambodia's peoples at that times. And then you can see in here that is the versions that we modify from the heating system that we use. Maybe some version without the heat hot water storage tanks. Some version also we use the fat plate and also some version that integrate with together with the two panel series, also with the low cost versions made of the plastic pipe or the copper pipe that it can apply for the public toilet or the individual household. Then that is the one's lesson learned that we uh, understand from the implementations and also develop into the new versions of the solar septic tank during that times. But not only that ones, we also working with the partners, the University of Glasgow that led by Professor Bill Salone and Dr. Stephanie Cornelis to understand the microbial community insights. From this point, we try to understand the operational factors that might affect in terms of the microbial communities, because when we deal with the temperatures, that is directly related into the community insights, and then we try to understand what kind of the conditions that can promote the good performance for the solar septic tank. Then we work on the collects the samples during the operation period, and then we come up with a kind of the data on the microbial communities. And then this is a part of the further investigations that by using the microbial community to support the operational details. In summary, this is the overall approach from our teams that Professor Jongrak already mentions about the existing situations that we survey, and then we try understand the situations, understand the need of the peoples, and then we develop in the first step that we call the proof of the principles by set up of the experiment. At that time, I'm also the PhD student to work in the lab scale for the solar septic tank, and I think that is maybe more than 6 or 7 years ago. And then also we develop step by step into the proof of the concepts with the integrate with the solar heated waters, and also the verifications of the test with the several area or several the partners. And not only that ones, we try to prepare the versions that it can be uh, produced or maybe commercialized in the futures. And then we also talk with the product designers to develop some versions that can be further commercials of the our technologies at that time. And then this is some of the details that we also working with for the develop of the products of the solar septic tank. Then that is the concept for the individual household with the volumes about 600 liters at that time that we designed. And also to comply with the ISO standard or the discharge standard of the Thailand. Then we know about the solar septic tank. It can enhance the performance of the maybe conventional treatment systems. But if we would like to achieve the higher standard, we try to investigate more in terms of the post-treatment, and then we use a kind of the constructed wetland unit to further treat it, or polishing of the effluents that it can meet in terms of the some standard that it can be the promote in terms of the complete set of the solar septic tank that can integrate with the kind of the post-treatment system. That also the area that we are working in these kind of the investigations and also the research developments. I think that is all the ideas that we try to come up with the new solutions or new sanitation paradigms that it can apply for the countries or the regions in the futures. And then you can see these pictures. The canals we call the Sangsap canals is quite dirty now, and then we hope in the near futures, maybe 5 years or 10 years after these kind of the implementations, we can promote our Sansap canals into the Venice Canal in the futures. I think that all for the detail that we would like to share to you all. Thank you very much.
Okay, thank you very much, Dr. Tachai, and also Professor Jongrak, that having the insight of how we develop the technology. Solar septic tank is one of them. And I'm sure that there would be many of inquiries addressed to Professor Jumrak and Dr. Tachai as well. I don't know, is there any questions from the audience? Yeah, questions about that. Is it possible to purchase or order from anywhere in the world this solar septic tank? It seems like very interesting, but whether it is up to that commercializable products already or not. Dr. Tachai?
Yeah, maybe we can share about this this uh, this view. Like normally we try to different approach when compared with the other technologies, because this is a kind of the technology that we develop from the labs into the prototype, and then the point that we try to would like to work more is just try to implement and verify, and then at that time that we just have the kind of the versions that to implement as the prototype versions. And then I think right now it's not yet for the purchase or the commercials, but we have the partners that we develop kind of the maybe the tank version for the solar septic tank that available for the purchase, but maybe just it's like a made to orders. It depends on the condition as well that we can provide these kind of the technologies to the specific case.
Yeah, it is not very fortunate like the cyclone cube in the past that we developed from AAT technology as well, but that was invested by Mr. Atahut, who has a passion on this sanitation system. Unfortunately, he didn't get impressed with the solar septic tank yet. So perhaps we need to explore Mr. Atahut's second person's second to this, and also perhaps once the commercialized cyclonic concept it is done in the field. So in the future, he may like to take up this solar septic tank to develop further into the commercializable market products. So I think that that would be the possible things that we can do at least in this sense. Is that okay, Mr. Atawut?
Okay, let's try.
Thank you for the very interesting presentations, Professor Chongrak and Dr. Tachai. I don't see any other questions popping in on the group chat so far, but I would encourage all the participants to pose their questions or comments. Some of them mentioned that they're really impressed by the work that the Thailand team does. As usual. So maybe what we can do is maybe to start a small discussion, and then we can see if there are additional questions to add on. Professor Damir is also going to join us in the next couple of minutes. Maybe we can start with a small discussion on how do you see the whole process? How do you see the whole evolution of all these non-sewage sanitation systems developing in the future? Do you think that these technologies would be able to support achieving the SDG 6, particularly in Thailand? What is your vision and intake from your work?
Perhaps I invite Professor Jongrak first.
Thank you. Yes, because SDG 6 is about clean water sanitation. As I mentioned earlier, the present sanitation situation in Thailand, we still have to improve a lot. So we think that with the solar septic tanks, then our wastewater treatment become better, our water quality in the canal river become better, and the pathogens are inactivated. So we hope that with this implementation, hopefully in the near future, then SDG 6 could be achieved from our technology. By the way, our solar system is supposed to be cost effective and accessible by the poor people. So the cost function should be affordable by majority of the people. Thank you.
Thank you. Mr. Atawut, is there any compliment to that?
Actually, we are working together with the government officials in Thailand as well to improve the sanitations in the communities. We try to set up the project with our aquatic tanks to improve the wastewater from community to prevent this direct discharge to the canals in Bangkok. So I think it should be a part of the the very long success together on improve the sanitation in Thailand. Yeah. But we we will try even like a small effort, but we will try more.
Yeah, definitely, we have to work with many other agencies, government or private sectors that we can contribute to the SDG 6 that apart from the treatment products that we have. What about the fecal sludge, the sludge, the remaining that we still need to improve more? Of course, all of the households in Thailand, we cannot just ask them to change to either cyclonics or to the solar septic tank yet. But still, we have huge tons or thousand tons of the sludge or the fecal sludge to be treated further. Then we need more innovations. We need more technologies to treat that according to the safely managed sanitation. Otherwise, again, that we may not be able to comply with the SDG 6 indicators that we cannot get, even if we try to apply our technologies, cyclonics or the solar septic tank in Thailand. So that is, I think, my ideas. So I think we have Professor Damien now. So thank you very much for coming again, Professor Damien, and initiate this kind of interesting session.
Thank you. And I would like now to introduce Professor Bojanovic, who just joined the session, maybe to say a couple of words.
Yeah, so I joined the session live now, but I was listening to you almost all the way from the beginning. So I welcome this third keynote series, and it was fantastic addition to the and complementary addition to the first keynote series, where we had heard about the winding road to innovation from experts which are busy with the sewer sanitation, and this is now more on the non-sewer sanitation side, and that's very complementary. But what is interesting to see that underlining principles of how to turn invention into innovation in the shortest period of time are common. And also what is a common is that we need to shorten that time of when we go from the idea to wide commercial application of technology, which is now probably around 10 years. And this is just too long. So we cannot afford anymore a decade to get something on the ground. And what is our experience, and it also comes from your presentations, that pretty much engineers have solutions available, and it is about finding a launching customer and convincing the market and changing the perception of the market and of the people about these technologies. And that is also shown today as probably one of the barriers, and then it also shows how important it is to have the industry behind and the companies who do believe in the technologies and take them on board from universities and institutes, develop them further, and commercialize them. And that, of course, that is not part of the university's work. So that connection is necessary, like you also showed today, but also it's necessary to have a demand on the market. Without demand on the market, any invention cannot be turned into an innovation. So these three stakeholders are essential to develop and apply new things, and that also has been shown today. And I enjoyed to see also our former PhD students around you, Tamarat and Professor Paul Praset, and that they are still involved and enthusiastic. So that's great because I think it's on the young people to, slowly take over from the seniors and go with even more energy. And we will always be there to support further. But I think such presentations as today are essential for younger generations to encourage them to innovate and to apply their innovations.
Yeah, definitely, it's very interesting that we see the products or the outcomes of the projects that we work together with IHG and many other universities. Akshay is one of the very first graduate from that program, and then he continue working in this area, and also that try to come up with this innovation and try to get into the market. But unfortunately, we have no good partners like SCG Chemicals to invest in this solar septic tank yet. But in the near future, I hope that once he can launch successfully the cyclonics, then he can turn his mind into the solar septic tank in the near future. I think that's related to the question from Mustafa. So he asked about the readiness of the cyclonic, including the introduction in the market. How do you do, Mr. Atterwood?
So I think Mustafa, you are come a little bit late, right? So we already discussed this point. Anyway, as we also discussed with him before, so I think that the synchronic, especially for aquatic part, especially the water treatment, working with septic, it's ready now. We start productions in South Africa already. It means we try to do a local made. And if the South African production is completed, I think next 2 months, I think we will have the first commercial that local made in South Africa and work with the government projects for 3 or 5 units. And then we will have another like more 20 unit for the next project tender for residential project. So I think more or less in terms of my strategy is on made it local and sell it local to make very cost effective. So now we can do a lot cost reductions by doing that. And I think we are combining with our partner experience also make the product cost is cheaper. We try to like work together and to make the complexity to be more like flexible and more easier. And sometimes when it's come from university, it means like a very complicated thinking because like the researcher try to complete and make it like perfect. So but when you're selling in the market, so we think a different way. So we try to make it simple and easy to production. So another way. One thing that I just want to add on about the commercializations is the when the researchers in the university they try to think it's a more or less and more on technology push. I think that it's great by himself, by the brain, and think it's good. But for me, when I select the product to launch in the market, I think about the value propositions of the product is the key interesting. So how industry select the technologies, I think it come from the value propositions. So I think all the researchers, I mean a lot of students here that are learning about the on-site sanitation should understand more about the value propositions of the product. Once you decide and develop the technology, please ask who will buy the technologies and what is the cost that they will buy. So try to think about you are the startup company. You are the CEO of the company of the startup. You want to sell that. That is the key. So when I select the technology, so I mean that this one is good. I think I sensed about the market perceptions that if we trick some things and make it very cost effective, this one will be value to the end user and customer. So I encourage the young engineer that are working today and listening here and try to think about the value proposition of your technologies and how the technology is value. So invention and innovation is a difference. invention is sometimes it's useful, but useful for one, for who just only use mean invention using in the backyard. But if it's useful for public or in the people, so maybe that is innovations. So and if it can be commercial, it will be very good commercial innovations. So that's the key.
Thank you. Thank you so much, Atawat. This is very important, and it's a great message to our students and to all the young generation of developers. Maybe to continue with this, I would like maybe to elaborate a little bit more on another important aspect of commercialization. And I think Professor Tamarat, you already mentioned about the role of standardization. I know that you all have been quite involved into the process, and perhaps maybe you can share a little bit more on that part. Because that's also an important stage. We speak about innovation, we speak about technologies that are new, creative, inventive, but how do we ensure that the quality of this system is high and they are performing in a way that all the products are meeting the standards that are required for the environment and health, of course.
Yeah, I think that's also very important to convince industrial partners that to which standards our technologies can comply with, and then they can sell the products or not. For example, that in Thailand we haven't adopted the ISO 30500 yet, but fortunately we have the Thai standards for this wastewater treatment system, the decentralized wastewater treatment system, just recently launched, I think, a couple of years ago. So we have to test according to the protocols, the testing protocols that we can set the different patterns of the flow, the concentrations, and then monitoring system as well. That if we can comply with, if those the technology can comply with the standards, then it is get the stamp to say that yes, it is sellable, it can comply with the standard in Thailand at least. Then I think in other countries, I think that's also very important, whether or not you like to get the standard from ISO or you can develop your own at least at the beginning stage. I understood that to comply with the ISO 3500, it takes some time, and also the testing cost is quite high as well. So that it is another challenges in the testing of the products, that it is sellable or it is comply with the requirements from the governments or not. That also, I think it would be another lesson learned, that we have to set this kind of enabling environment to the market, that not just because we would like to sell the technologies, but we need to set the ecosystem to ensure that yes, our technology is sellable because it is compliant with the standard. Then the company, the industry would like to get our technologies to further develop until the market ready for purchasing these kind of products. That's what I think it is very important. Second to that is about the laboratory. I think Tina, you are the leaders of this kind of methodologies in analysis of this kind of PFAS sludge or the samplings of this kind of treatment system. It is also very important that we need to have a standard testing lab as well. Otherwise, one lab from university, we may use different kind of methodologies. In particular to the PFAS sludge or the sanitation system, we may have different concentrations from one to the others, and many other interference in the analytical approach. So that somehow we need to upgrade our analytical labs in our countries. That yes, we need to have that. Then we can prove that this is the conforming with the methodologies, and also that we can prove that your analysis can meet the standards or not. I think that would be two things that from the economic point of view, is that we can contribute to create this kind of ecosystem for the products to reach the product into the market. That's what I thought. Yeah.
Thank you. I don't know if any of the other speakers would like to elaborate.
Yeah, probably just if I can join, probably the issue of standardization and also laboratories and methods would be a proper topic for one of our future keynote series.
Yes, yes, most definitely.
So I would also invite Tamarat to join us, probably
Yes.
with other co-authors of the developments, and to have a common session on that quite soon, before the summer or during the summer, and then we can further talk about that and show some case studies. The other topic I think which comes very close to what it was presented today, but also in a first keynote series, is about patents and protection of intellectual property rights, and all these little but very important things which are uh, in a way kind of hindering also the process in a way, but also at the end makes it possible. But they also take attention, and from the questions from the previous sessions, we get some questions about that, because our students, and especially young students, really are curious about this. They don't know how to proceed, and they ask for guidance. And I think this topic is a little bit in the background of what was shown today, but is essential that we also share these experiences. So probably another idea for the future would be that we could, get some people with experience with the patents. And also in the Netherlands here, we have a just next door, actually, from here, about 10-minute drive, European Patent Institute with the hundreds of people working there. So we can get someone from there as well, and have that session as well. So then we have a good packages around innovations. So that's maybe something that we will take on board in the coming weeks.
But maybe we have a couple of more minutes. Maybe we can hear some experience, maybe from Mr. Atalat, if you have any experience, or Professor Chongrak. Any advice to start with?
Okay, as a teaser.
As a teaser, yes.
So actually, for the patent things, I think when you work with the industries and universities, maybe we think in different way. Um, um, what is the industry need when we work with the university about the patent things? Is uh, we want to make sure that when we patenting things, it means it's value to business, because you do a patent is like your investment, right? So because you need to pay for, and you need to maintenance the patents, and even you have to select the countries. It's quite difficult to when I starting the reinvented toilet products. Um, the IP guys asked me which country that you have to filing. So it's quite new products to ours and to the world as well. I don't think so. I don't know that we should start to say where first, but that's why it's more like difficult for us to select which countries. But okay, we start with the PCT system first, and then select the first country that is easiest way to like fastest one that you can get granted the patent first, and then we have a time like 3 or 4 months after that, maybe during the PCT period, right? And to select the right country. So it means that you have to work like in parallel to develop the market during your filing. After you get a granting, and then you do it. So it means that the technology and industrial partner have to work in parallel to do which country that is your target countries and filing. So, and that is my point. Maybe we no need to filing every countries. I think that just the country that you think that um, your product is will have a lot of competitions. But in some country, I think you can treat it as the trade secret and to run your business by your own, right? But you will see that I have a product to produce in different countries, not in Thailand. But it's not all of the product that produced there. It means some a core technology is produced in Thailand and ship some part to assembly in other. So this is another way that you can keep your technology with you, right? And it means that you no need to do a patent filings in every countries, but it depends on that you can keep some technologies and secret everything with you or not. So I think this point maybe we think differently.
Thank you.
Yeah.
Hello. Yeah.
Well,
Yeah, I have just a few comments. Yes, this is a very good issue, Damia, to talk about the pattern, because like in academic or researcher, the pattern issue is like a dilemma, because when we do research, of course, we want to come up with new idea, new technology that will help solve the problems like environmental problem, health problem, and we hope that they will be used in the wider scope. But we understand that when new ideas come up, like today, the solar septic tank, if some company got idea, like we show today, if they come up with the commercial product, if they make it very expensive, then well, most people in the less developed country cannot have access. Then, of course, our result will not be very useful. So this is a dilemma, and I think I support your idea to have the session how to make it the balance so that well business also will get benefit, researcher will also have the encouragement to do more work, and public at large will have benefit of our hard work. Thank you. Damian.
yeah. Thank you, Professor. I think we can pose this dilemma. Indeed, as you said, the balance. Is
Yes.
open access versus patenting and protecting the. How much is the patenting and protecting the rights actually hindering the developments and uptake of the technology globally?
Yes.
So I think that is very important because different stakeholders are involved, and different stakeholders definitely will have different opinions. And I'm curious to listen to these opinions and to know more about that as well myself.
I think this is another question, I think, addressed to the Thachai. So can you answer that, Dr. Thachai?
I can maybe perhaps I'm not sure. We have about 3 minutes to wrap up. We can encourage questions after that on the chat box. I'm not sure how are we doing with the timing.
Yeah,
Do we have another time for
I
questions?
think we can maybe give Tachai a chance
Okay.
to give a short answer, and
Yes,
then we can close up.
Yes, that's the question.
I think for the questions about the solar septic tanks, the first point that normally the principles of the designs that you can see is like normally we design that is based on the users affordables at the beginnings, like they can adopt the solar septic tank easily as the conventional treatment unit. But the thing that we work is about the key designs in the maybe the same principle with the conventional one, like a numbers of the users and then the flow rate, and also it can be designed in terms of the energy required in the tanks at the ends. And then that is the case that we work before to make the use of the solar septic tank in terms of the implementations. And in some case, like they talk about the weather conditions, and then somehow you can see in the various version of the solar septic tank. Normally, we design in some version with the hot water storage tanks, with the hybrid systems, and then with the support of the heating system that we can use. And then one of the version that we work, that we try to absorb the heat from the maybe air compressors, the air conditioners, that it can available to use in the communities, in the gas stations, or maybe some area that it can avoid the condition for the weathers. That also the one point that we also working on, based on the weather condition or in the monsoon or the winters. I think that I Is that okay for the questions?
Yes, thank you. That's a wonderful answer. Thank you so much. So I think we are close to the end of the session. So I would like to give a round of applause to our virtual applause to our presenters. Thank you so much for your time and sharing your knowledge. It was very interesting and another invaluable contribution to the GSGS Keynote Series. Please follow the next sessions because we are trying to provide different variety of knowledge coming from different regions of the world. So make sure that you follow this series there once a month. So we would soon advertise about the next series. Damir?
Yeah, I just would like to thank Tamarat and the team in Thailand for preparing and organizing high-level speakers and very interesting content. And I'm happy that this is also recorded, so people who could not join us today, they have ample chance to go through the preparation through the presentations today. So thank you guys, and it was a pleasure to see you again. And I hope we see each other soon, also live somewhere.
Yes, thank you very much, Damir and Tina, for organizing this kind of interesting event. Thank you very much.
Thank you.
You're welcome.
Thank you. Okay.
Thank you.
The Global Sanitation Graduate School is the world's largest platform for capacity building in city-wide inclusive sanitation. We offer educational programs in sanitation with a focus on participants from low and middle income countries. We are expanding rapidly and welcome new members. Interested? Contact us today, www.sanitationeducation.org.